Welcome back, everybody. This is a continuation of my previous video of non-rigid transformations. And in this video, I'm going to talk about horizontal stretch and horizontal compression. Now, if we look at our guideline here, we can see that we have y is equal to f of c of x, where if c is greater than 1, then the graph is going to compress horizontally. Versus if I have y is equal to f of c of x, and if c is between 1 and 0, then the graph is going to stretch horizontally. Now, as you can see, we have the graph f of x is equal to x squared. I already went ahead and graphed that. This is our basic function. Then we're going to see how the graph g of x is going to behave. And we can see that since we have 2 in our function, well, 2 is c in this situation. And since 2 is greater than 1, then we can say that this graph that we're about to graph is going to compress horizontally. And then looking at h of x, we can see that since half is between 0 and 1, the graph is going to stretch horizontally. And I'm going to need some space here to construct our table of values. So I'm going to go ahead and kind of like fold this in half so that just you can see what we're talking about here. Now if we begin by making our table of values, x and g of x. Now since our plane is constricted to increments of 4 on each side, so I'm going to go ahead and choose a smaller value instead of just choosing -2 and -1 and so on. I'm going to start with, let's say, -1. And then I'm going to choose -half. And then work my way up to 1. So we have -1, -half, 0, half, and 1. Okay, so if we go ahead and do this, we have 2 times -1 squared. 2 times -1 is going to give us -2, and then -2 squared is going to give us 4. We have 2 times -half squared. 2 times -half is going to give us -1. Then -1 squared is just 1. We have 0, so 2 times 0 squared is going to give us 0. And then 2 times half squared. 2 times half is 1, and then 1 squared is just 1. And we have 1. 2 times 1 squared is going to give us 4. We can go ahead and plot this. We have -1 and 4 as our first point, so -1 and 4. So this point is all the way up here. We can just put a dot. Our next point, -half and 1. So we have -half and 1, so it's all the way at the bottom right here. We have 0 and 0, which is just at the origin. We have half and 1, so half and 1. Then we have 1 and 4, so it's all the way at the top right here. Now if we go ahead and connect those dots, it's also going to be a parabola. should be a smooth curve here. There we go. And of course, this is going to go on forever. You can see how the graph kind of compressed a little bit. Compressed a little bit this way on each side. Now if we go ahead and do our second set of values, we have our function h of x. I'm just gonna, here we go. So we have a table here. We have x and h of x. Now, since we already have half in there, I'll just go ahead and choose our normal values, which is -2, -1, 0, 1, and 2, just to avoid fractions. If we plug in -2 in h of x, we're going to get half times -2 and all this squared. So half times -2 is going to give us -1, and then -1 squared is just 1. Now we have -1, so half times -1. Half times -1 is going to give us -1/2. And then -1/2 squared is going to give us 1/4. And we have 0. Half times 0 squared, this is going to give us 0. Then we have 1. So half times 1 squared. Half times 1 is just half, and then half squared is 1/4 again. And we have 2. We have half times 2 squared. Well, half times 2 is just 1, and then 1 squared is just 1. So there we have our table of values. We can go ahead and plot them. We have -2 and 1, so -2 and 1, which is somewhere here. There we go. We have -1 and quarter, so -1. And since this is half right here, so I'm just going to go half of that distance. So -1 and 1/4, so somewhere here, let's say. And then 0 and 0, that's just the origin. We have 1 and 1/4, which is here, 1 and half the distance in the y direction. And we have 2 and 1, so that's 2 right here, and then 1. If we go ahead and graph this, this is gonna look something like this. And then the same on the other side. Now the graph goes on forever, so it's gonna look something like this. And since our C value, which is half, is between 0 and 1, and our guideline states that if it's between 0 and 1, the graph is going to stretch horizontally. And evidently, this is what we can see here compared to our original function. Our original function lies between g of x and h of x. So our original function stretched this way, as you can see in front of you. So that's it for today. If you enjoyed this video and would like to see more, please remember to like it and hit that subscribe button. This is going to help grow the channel more. Please don't hesitate to leave a comment in the comment section below if you have any questions or concerns. I'll try to make sure to do more problems regarding non-rigid transformations. And thank you for watching again, and we'll see you next time.